My name is Luc Boulogne. I'm a PhD candidate at the Thera Lab, and from March to July this year, I've been part of a large collaboration between Thirona, the Radboud University Medical Center, the Academic Medical Center in Amsterdam, and Fraunhofer Mavis. Together, we worked on an AI solution for automatic assessment of COVID-19 from chest CT images. Today, I would like to share with you the main results of these efforts. This is the CoRADS AI system, which we published in July this year in Radiology. CoRADS AI is an automatic system that analyzes a CT scan for the presence and severity of a COVID-19 infection. It works in 3 steps. In the first step, it segments the lungs and the pulmonary lobes from a CT scan. Then, in the second step, it finds the regions of abnormal lung tissue inside the lungs. And lastly, the system classifies the patient according to the CoRADS scoring system. I will now briefly go over these 3 modules. The automatic lobe segmentation of CoRADS AI was made by YG Xie. Xie was already working on this for over a year. He quickly adapted his system to be able to handle COVID scans. He managed to publish this in May this year in a special issue of IEEE Transactions on Medical Imaging, one of the best journals in our field. The main benefit of this system is that it can learn the structural relationships between different parts of an image. This is something deep learning segmentation systems can struggle with, but it is important for segmenting large structures such as pulmonary lobes. In severe cases, COVID-19 causes lesions to form. Thirona annotated these lesions on 180 CT scans for us. Using these annotations, we trained many different neural networks and tried different approaches to segment the lesions. We found that the special architecture proposed by Fabian Eisensee from Heidelberg gave the best results. This architecture is called the No-New-U-Net, and it automatically optimizes all the hyperparameters in a 3D U-Net. That the No-New-U-Net works best shows that in applied AI research, using an existing method sometimes works better than inventing a new network architecture. The final module performs a CoRADS classification. Also here, we tried many different approaches. We found that 2D slice-based approaches did not work that well. However, almost all papers that were published in the first few months used these simple approaches. We got the best results with an architecture called the Inflated 3D Convolutional Neural Network. This is a type of network that was also successful in other recent publications on lung cancer detection in chest CT. We also added the lesion segmentation from the previous step as an additional input to the network to further improve our results. To gain more insight into which parts of the CoRADS scoring module were important for its performance, we performed an ablation study. Here, we eliminated components one by one to see which ones improved the performance of our system and by how much. These are some results of the ablation study. The 3D variant of our model is shown in blue. The 2D variant is shown in yellow, and other 3D variants where one component is ablated are shown in black. All components seem to help slightly, but there is a large difference between the performances of the 2D and 3D model. The main takeaway here is that you should use 3D models for COVID-19 scoring. Just looking at 2D slices individually is less effective. This is also in line with the way radiologists score CT scans. When they score a CT scan for the presence of COVID-19, they inspect different orthogonal views so that they can take into account 3D information. So those are the 3 modules that make up CoRADS AI. Here you see an illustration of the output of the complete system. At the top, you see multiple slices of a single CT scan. Then, in the middle row, you see a lobe segmentation for this CT scan. And in the bottom row, you see a lesion segmentation, where the lesions in different lobes have different colors. The bottom left shows the probabilities that the system assigned to each CoRAD suspicion level. Using the lesion segmentations our system provides, CoRAD's AI also computes the severity of the COVID-19 infection. This is shown in the bottom right side of the slide. CoRAD's AI computes the severity score for each lobe based on the percentage of affected tissue. It also outputs the severity score at the patient level, which is simply the sum of the lobe-wise scores. We carefully evaluated our system on CT scans for which we also had PCR test results. To do this, we obtained CoRAD scores and severity scores with the help of 8 different radiologists and other healthcare providers. We compared these scores with the output of CoRAD's AI. In this plot, you see an ROC curve with sensitivity on the vertical axis and the probability of false alarm on the horizontal axis. The performance of the radiologists and healthcare providers are represented by the numbered circles. As you can see, the performance of CoRAD's AI is very close to the performance of radiologists and healthcare providers. We also investigated the distribution of CoRAD's AI's severity score output. Here, you see these outputs grouped according to the scores by the radiologists and healthcare providers, which vary from 0% affected tissue on the left to more than 75% affected tissue on the right. On the vertical axis, these categories are indicated with the same colors. As you can see, the system is quite good at sorting the CT scans into the correct category. We made our solution available online for free on the Grand Challenge platform that our group has built. It allows us to let anyone around the world upload CT scans. You can then view the results in the workstation that you see here. In this workstation, you have access to all the information that was present in the report I showed you before. But you can also interact with it by toggling the overlays, scrolling through the scan in different orthogonal views, etc. We put the link in our radiology publication, and since radiologists from all over the world, especially from North and South America, have been uploading many CT scans. So, those were some main results of our efforts during the pandemic. This was today's last lecture on diagnostic image analysis for COVID-19. Thank you for your attention.